I know this flip-flop's no longer needed. This transistor and this filter circuit's no longer needed. And possibly I don't need this guy. I need to figure out what the other side of the op-amp's doing. So let's check that out. Oh. Well, here you see it. I bet you that's ground. So pin 5, which is the positive input, is hooked to plus 5 volts. Pin 6, which is the minus side input, is hooked to ground. So they basically have disabled the other half of that op amp. So he can go away. He provides no practical purpose or practical use to the circuit whatsoever. So this chunk here is going to disappear along with that. And back to the soldering we go. Let's start with the IC first while the solder sucker's good and hot. Now when I flip back and forth on a card like this to look at the joints, what I'm looking for is the joint on the solder on this side of the card to flow. Basically the surface of the solder changes color a little bit. It's sort of hard to describe. Like the texture of the solder changes once it's hot enough that it melted. And the reason I want to wait for that is so that I suck all the solder from one side out the back side of the card, so I can cleanly pop the chip out without ripping the pads off the front side of the card. So if I only sucked the solder off the back side, the chip would still be attached to the pad on the front side, and when you pried it up to pop it out, it just ripped the little copper pad and possibly the trace off the card, which would be bad. Now, I'm 99% sure that I don't need these spots, so it would not be the end of the world, but just in the off chance I screwed up, it happens a lot, I want the ability to put these back on easily. Without having to do a bunch of pad repair. And so now that we have that off, you can easily see, here's that trace going out that way. Oh. Where did that trace? Yeah, that's the one that had all the pain tracing. And then there's the reset line. This line loops up and around to there somewhere. This one comes down. So yeah, it all sort of works out about like I expected. Set, reset, set, reset, set, reset. So it looks like all the sets and resets go to this chip, which is a octal or 3 to 8 decoder, which makes some sense because these LEDs out here, it's going to come in, hit the set bit, do its row multiplexing, and then come and set the hit the clear bit. It's sort of similar to these, but instead of addressing, taking the address bus from 8 bits to address one of these and putting the data on the data bus, they're just doing it all in this chip. Now that said, they may still be hooking this to the data bus, so I need to trace it some more. But before that, we're going to make all this stuff disappear. Okay, let's see if we can get him out. And there we got a little comparator. Totally reusable. Okay, let's go for the transistor next. Now I got 2 out of 3 legs free. Oh, there's the third one. I hadn't quite heated it up all the way through, so again, And my first little capacitor. Another little capacitor. Okay, apparently I didn't get this guy quite unsoldered. Okay, that's free. There. Capacitor. Resistors. Okay, now we just got this little group down here. And there you have it. The entire pen input circuit is removed. While I'm sitting here, I'm going to remove the connector for the sign-to-sign interconnect. Just, it's a connector. It's pretty straightforward. All the pins go out, and if I take it off, it'll be easier to see what might be underneath it for connections to it. And let's see if I can get this to pop off. And voila. And a connector. Interesting, there's a little enable jumper right there, which connects from ground yeah, that's ground. Connects from ground to 1, 2, 3, 4, 5, 6 over. 1, 2, 3, 4, 5, 6. Yeah, it just goes from this jumper to ground to a pin on the connector and also runs off to something. So apparently there was an option set by this jumper on whether or not this sign could be chained together. Now, this might have been a bit to say, hey, I'm in slave mode, don't use any of your built-in code, just sit and wait for commands over the slave port. Or, it could be that, if this jumper's here, it has the feature, and if it doesn't here, it does not. It's marked EN, so I'm guessing enabled, but honestly, don't really know and never will. So, since I'm in this area, I think first I'm going to go back and trace this guy out. And if the only thing he drives is this chip, he's going to get nuked. The other thing I'd like to trace out is probably all the connections to this sign-to-sign port. My guess is this guy is a serial port back to this UART, but until I do some tracing, I won't know for sure. Oh man, it's almost... I think my clock died again. Huh. Just put a new battery in that clock and apparently it wasn't so new. I'm going to pause the video here and go get a new battery for my clock. And I also might switch batteries on my camera just in case it's starting to go dead.